Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this channel we cover all things Gen Chem related. On this video, I'll be covering standard formations and help you to understand how to calculate heats of formations. Let's get started. So to first ground set us on some standard vocabulary, the standard state is considered to be the state of material at a defined set of conditions. Typically for a pure gas, this is at exactly 1 atmosphere pressure. And for pure solids or liquids, its most stable form at exactly 1 atmosphere pressure and its temperature of interest. And this is normally at room temperature at about 25 degrees Celsius. And we're looking at substances in a solution with a concentration of about 1 molar. Now, the standard enthalpy change, or delta H, is the enthalpy change when all reactants and products are in their standard states. And the standard enthalpy of formation, or delta HF, is the enthalpy change for the reaction forming 1 mole of a pure substance or compound from its constituent elements. Now, the elements must be in their standard states, and for the delta HF, or the enthalpy of formation, for any pure element in its standard state is going to be 0 kilojoules per mole. So if you're looking at a table of information and trying to figure out what is the standard state of something, you can look for the substance that has 0 kilojoules per mole listed. So shown for you here is a small snippet of some of the different standard enthalpies of formation. And you can see for a variety of compounds, they have various enthalpies associated with them. But if you're looking to figure out what is considered to be the standard state of that specific element, you look for where its enthalpy value is 0. So for instance, carbon, we would say that the graphite form, the solid material, is its standard state. Or for oxygen, we would say O2 is its standard state. So that's how we're going to use this table. So for formation reactions, the reaction of elements in their standard state to form 1 mole of a pure compound are considered to be those that are formation reactions. And so again, if you're not sure what is considered to be the standard state, look for the element in which the enthalpy value is listed as 0. Because the definition requires 1 mole of compound to be made, the coefficients in the reactants may end up being fractions as you have to adjust to them to ensure you only have 1 mole present. When you're writing out these reactions, these formation reactions, so shown for you here, an example is for carbon monoxide. Well, we know carbon monoxide involves carbon and oxygen to come together to form this compound. And so as you're predicting this formation reaction, we need to remember that the elements must be in their standard state. So again, if we look on that table, we would find solid carbon is 0. And then for oxygen, the oxygen standard state is the diatomic version of it, which is O2. So in reality, we would have 1 carbon plus O2 to get carbon monoxide. However, as we've just learned, we need the coefficients, we need the reactants to be reflective of only 1 mole of the particular substance. And so we have to adjust the coefficients accordingly in order to have just 1 mole of each thing, 1 mole of carbon, 1 mole of oxygen, not O2, in order for us to do this formation prediction. And so what we end up having to do is put a half 1/2 as a coefficient for the oxygen to bring it into its standard state. So then as we're calculating, the reaction can be written as the sum of the formations reactions or the reverse of the formation reactions for any reactants and products. So the delta H for the reaction is the sum of the enthalpy values, so the heats of formation, for each component of the reaction. And so we can use a really simple formula to help us out here, where you're taking the sum of the enthalpies of formation for products times their mole amount, so N is the mole, or the coefficients, and then minus the sum of the enthalpy for the enthalpies of formation for the reactants times their respective mole amount or coefficients. Okay, and so we can adjust this and predict the overall heat of the reaction by using this simple equation. And so shown for you here is an example of taking methane plus oxygen to produce your carbon dioxide and water. And so if we were to break each of these parts down and look up the formation information for each of these, you would find on the table for CH4 that there's a value of negative 74.6 kilojoules. For the formation of the carbon dioxide, it would be negative 393.5. And for the formation of water, it would be negative 241.8 kilojoules. Now you'll notice here there's no value listed for oxygen, and that's because O2 at its pure state or its standard state, the value would be 0. So you could have one on here if you wanted, but the value would be 0, okay? And so now if we reference that equation that we just saw to figure out the overall sum of these enthalpy values, we would be taking the sum of the products minus the sum of the reactants, making sure we incorporate their respective coefficients. And so when we do that, we know that, well, we actually have to change the sign because, again, it's minus the reactant. So it was negative 74.6. So that would become positive 74.6. And we have the 393 and the 483 for the two products. And so since the mole amounts or the coefficients in front of each of these is 1, we don't need to multiply by any factor. But just to, again, step it out for you here, we're basically saying the heat is equal to the sum of my products, so 483.6 plus negative 393.5 minus the sum of my reactants, which is negative 74.6 plus 0 for the oxygen. Well, that makes this become positive. And when we add all that up, we get negative 802.5 kilojoules as our final answer. So this is just an alternative way for us to go about predicting these enthalpies of these reactions if we're given information about the heats of formation. I hope this information helped you understand standard formation and heats of formation. Make sure you guys like, comment, and subscribe, and let me know what other content you would like to see. See you guys in future videos. Have a great day. Bye-bye.